energy and structure would be what is called the vacuum, meaning that we think of what's between things as emptiness, but there's not really any reason to think of it that way, that we could just as well think of what's in between things as fullness. And that the things we call reality just emerge from the vacuum and returns to the vacuum, emerge from that fullness and returns to that fullness. And maybe if I can give you a visual, you could think of water in a pool. And if I pushed a plate in the water in the pool, I would make two little vortices on each side, two little vortex, two little swirls. And they would be spinning in opposite direction. And if, I could say, oh, there's a swirl, but the swirl is just a dynamic in the water of the pool. And if I didn't know that the water of the pool was there, and I could only see the dynamic, I would only think that that's the only thing that exists. I wouldn't know about the water.
Right.
And why would I miss the water? Well, how would we miss the fullness of space? Well, because space is everywhere. The atom is made out of 99.99999% space.
Yeah.
And so what we call reality is a little bit of a jiggle in the space. And we call that an atom. And we call that reality. And we say, oh, there it is.
So what?
But it could be just the dynamic of the space itself.
So what you're saying here is that the physical reality is an effect of something that is occurring in the vacuum.
Exactly. And that it emerges from the vacuum and returns to the vacuum.
Right.
Let's go back to our plate example in the pool. If you push a plate in the pool, you'll get two little vortices on each side. Now, if you look under the water, you'll find that the two vortices are connected by a string of air under the water. If you put your hand between that string of air, the vortices will disappear. And you'll think that the energy is gone, that the dynamics is gone. But if you take your hand out again, then they can reappear. And so what I'm saying is that I believe that, and the physics I've written supports that actually reality is blinking in and out of the vacuum at a very high rate.
Right.
And that just like a movie, which appears continuous when it's run at the right speed, but if you look at the movie itself, at the film, you can see it's a piece of, it's an image with a space, with an image, with a space, with an image, with a space. And when you run it fast enough, it appears continuous. I believe that matter, and we know, for instance, that the electron and the positron exchange across the, blink in and out. That matter is blinking in and out at an extremely high rate into the vacuum and out of the vacuum and into the vacuum and out of the vacuum. And because the vacuum is everywhere, when it blinks in, it informs the vacuum, and when it blinks out, it experiences the world. And then blinks it, and then it blinks in the vacuum again and informs the vacuum, and then blinks out again. And so the vacuum is constantly informed of everything that's going on.
Very interesting.
And go ahead.
Oh, yeah, I just said very interesting. I mean, that would suggest that it's a cycle rate or a specific frequency going on here. Then is that correct?
Yes, and that the cycle is at the speed of light.
Speed of light. Okay.
Yes, and that's why we experience it as a limit. And that this cycle rate, this very high rate of information transfer, is self-organizing all things. That because the universe, because the vacuum is everywhere, and as soon as it receives information, it knows what's going on, it self-organizes in a very rapid way. And that explains many things in physics that are unexplained. For instance, how is it that our planet produced so high level of complexity so rapidly since the Big Bang. People may think 14 billion years is a long time, but when we look at our planet, it's much shorter than 14 billion years, and we have, extreme complexity in biology that is available to us everywhere. And in order, if we did mathematical analysis of that, just by random function, the probability of all this coming together in such a wonderful, organized way is extremely low.
Right.
In fact, it's impossible. And, even for just one blade of grass to come together with all the complexity that's involved in it, it would take more than 14 billion years for that to happen, just by random function.
Right.
And so the tendency when we say that is for the religious people to say, it's God that organized it all.
Sure.
And what I'm proposing is that no, there's just a feedback dynamic in space-time that produce self-organizing systems. And that feedback, is what puts everything together and takes everything apart. And when it self-organizes, it goes towards higher and higher levels of complexity very rapidly, because it knows what everything is doing. So it knows what works and what doesn't work.
So when you say that suggests that it might have started out very chaotic then, and it's moving towards a higher degree of order. Is that right?
Yes, that it always moves towards higher degrees of orders and higher degrees of complexity, which, may seem to contradict the laws of thermodynamics, which says that things always go towards disorder.
Yeah.
But this is what the conflict is in physics, is that our law says that everything goes towards more disorder. So since the Big Bang, things should have decayed. But when we look at our planet, we can see that things have gone towards higher and higher levels of complexity and order. Let me give you an example. For instance, in a human being, if I took all the DNA that's inside a human being and put it end to end, you could grab that DNA and wrap it around the world 5 million times. So this is how much DNA that's inside a human being, completely self-organizing. There's about 100 trillion cells in the human body, completely, communicating across, large distances relative to a cell, between your toes and your hairs. Everything is making sure that everything's functioning properly, that your toe cells don't start making nose cells, and your nose cells are not making toe cells, and, everything is communicating and highly organized.
Sure.
And so what I'm saying is that there is an underlying organization, there's an underlying structure in the vacuum itself. And when we look in quantum theory, in order for all of our physics to work in quantum theory, there is a very important part that's not talked about much, and that is that the vacuum cannot be empty. The vacuum inside atom has to be fluctuating with energy in order for all of our predictions to be true, and all of our physics to work. And that fluctuation of energy in the vacuum in quantum theory is extremely high. That means in quantum theory, when they say vacuum, they mean something not empty, but something extremely full of energy. It's called vacuum fluctuations, or vacuum energy. And it's in the order of 10 to the 94 grams per centimeter cube. And just to give the listeners an